Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 926, flip string to monotone increasing. So a binary string is monotone increasing if it consists of some number of zeros, possibly none, followed by some number of ones, also possibly none. You are given a binary string S, you can flip S of I changing it from 0 to 1 or 1 to 0. Return the minimum number of flips to make S monotone increasing. So see here, for example, if they have given this example, okay, then I can tell you we want to either make this as 0 0 1 1 1. I can change like that. I can only flip this last 0. Okay, so by doing this, how many operations I did only one operation, or else I can also change 1 1 1 1 1. Here I did 3 operations. I changed this. Okay, or else I can change 0 0 0 0 0. Here also I did 2 operations. Okay, I have n number of operations here, but what is the minimum number of steps? Minimum number is 1, so 1 is going to be my output. Similarly, for this example, I can change this 1 to 0 and this 0 to 1 such a way that it can be changed. So this is going to be the minimum number of steps. Apart from that, you cannot do any minimum number of steps rather than this 2. Can you understand this? So this is how you want to change the given string into monotone increasing. Fine. So this is what they asked in the problem statement also. Fine. So how we are going to do this? So to do this, we can either go to greedy algorithm or we can either go to the regression algorithm. Can you understand this? So see here, we can either go to greedy or we can either go to regression. Why I telling you that we can go to greedy? Because here you have only 2 things, zeros and ones, and also you know how many number of zeros we came across and how many number of ones we came across. So greedy can be possible here, and recursion is also possible. So first let me finish this recursion and optimize it. So here I am going to use dp, and also after this I will be showing you how we are going to do this in terms of greedy. I want you to understand all the approaches. Okay, when you are going for an interview, then there you want to tell them as much as approaches you can. Okay, that's going to be the added advantage. That's the reason why I'm going to take dp and also greedy. Okay, for this particular problem we can do via dp and also greedy. Okay, and many people feel difficult to solve in greedy. Okay, actually greedy will be having only 3 to 4 lines of code. Okay, and the recursion in dp we want to write the recursion, then we want to optimize it. So it will be goes up to what 10 to 15 lines of code. And in greedy we want to think for all the edge cases. But meanwhile in dp, like in recursion, we can do it in easy. The thinking process is easy, but the time consumption will be more. In greedy, the thinking process will be more, but the time consumption is less. Can you understand this? So that's the reason why I am going to take these 2 things. In future, if this same problem occurred in your technical HR or in your technical round, then you want to think about the greedy. If you cannot come up with greedy, then swap the approaches to recursion. Recursion is quite easy. Okay, go to recursion and optimize it, and at last you have an optimized solution which is equal to the greedy approach. Can you understand this? So now let me just save this. So now let us just go with the recursion. Okay, fine. So if you don't know about the recursion, I'll be giving the link in the description for the recursion playlist. Just go and watch that and learn about recursion stack, recursion tree, and how the recursion works via DFS. Okay, after seeing all this, continue this video. Fine. Now the first step for the recursion is we want to design how the function looks like. So how the function look like means how many varying parameters we want. So see here the problem statement. Let me take some example. 0 1 0 1 1 0. Let us take this example. Okay, now in recursion we want the varying parameters. So how I am going to find the varying parameters? So see here, listen this carefully. I have this 0. Okay, whether I want to change this 0 or not, it should be depending on the previous and the next value. Yes, let us take the random value. This 0. I want to check whether I want to change this 0 or not. That's the one operation. I want to flip this 0 or not. That's going to be the one operation for this particular index. So how I'm going to identify it? So I will be checking its previous value. Its previous value. Its previous value is what? 1. 1 means absolutely after 1 there should be 1. So here I want to swap it. Here I want to flip it, right? So this is how you want to do in a recursion. I'll be drawing the recursion so that you can understand this clearly, okay? So where I'm going to start? I'm going to start at the 0th index, okay? I'm going to start at the 0th index and assuming its previous value is 0. Its previous value is equal to 0, okay? So let me go with the 0th index. So let me put 0, 1, 2, 3, 4 and 5. So here for the previous value we are just taking the value itself. We do not take the index number, because index number may go up to 10 power 5, we don't know. So it based on the input size, but there are only two possible values. Either it can be 0 or it can be 1. That's the reason why for previous I am just taking the previous value, okay? So what are the varying parameters we are taking? Index and the previous. So how I am going to start? I am going to start from 0th index and assuming my previous is 0, because always the sequence is starting from 0. That's what they have given. What is monotone increasing? It starts from 0 and goes on. When it enters to 1, remaining should be 1. Can you understand this? Zeros will be arranged at first, ones will be arranged at last. Okay, that's the reason why previous I took as 0 defaultly. Okay, now I am standing at this particular point. So it is 0. It is 0 and previous is also 0, which means I can tell you in two ways. Either that 0 remains 0. Or else I may change it to 1. For example, if I have 1 0, listen this carefully, 1 0 or 0 1 1 1 and 0, like that, like something like that, okay? Or going up like that. Here I may change this into 1 such a way that everything else will be valid. It may be some cases, it may occur in some cases, okay? So for those cases I am writing like I will be swapping, or I will be flipping this 0 into 1, okay? I will be flipping this 0 into 1, or else I will be leaving as it is, because it is a valid thing. The previous is also 0, right? So it is a valid thing. So I can do either of these two steps. What are two steps? One is I can either flip it. If I flip it, I will be going to the index number 1. After that, flipping that, I will be going to index number 1. What is my previous? My previous will be 1. I flipped it as 0, right? So it will be 1 and it is one operation. So I put 1 plus. Similarly, I can either go to next thing directly, because it is a valid thing. So if I go to the next thing directly, I will be going to the first index, but what is the previous? Previous value is 0. I didn't flip anything, right? That's it. Okay. Now I am standing at the first index. Okay. Now again, for this first index, what is my previous? Here. What is my previous? My previous is 1 and current is also 1, which means what it indicates is I can only take 1 alone. I cannot take 0 again. Because my previous is 1. How come the next value can be 0? I cannot take that, right? So I have only one possibility. What is that? It is 1. So just to take 1 itself, which means I don't want to do anything. Okay. So just take 1 itself. So 2, 1. Go to the second index and keep that 1 as it is, because the current thing is a 1, right? So the previous one will be 1 only. Okay. Similarly here 1, 0, which means I am standing at this particular point 1, the first index, and my previous value is 0, which means 0 and 1. This is what the current scenario is. Either I can keep this 1 as it is, or I can flip it to 0. Valid thing, right? So I have two choices. What are they? I can either keep them as it is, or I can flip it. If I flip it, it will be 1 plus f of, I will be going to the second index and I will be flipping it, right? So 0 will be becoming 1, or else I will be just keeping as it is, and moving on. So what is at the first index? It is 1. So the previous will become 1. Can you understand this? Okay. Fine. Similarly, now 2 comma 1. 2 comma 1 means I am standing at this 0. I am standing at this 0 and my previous is 1. Oh, it is contradiction. Can you understand this? It is contradiction because I am standing at 0 and my previous is 1 means it is not a monotone increasing, right? So what I have, the only one step I have is 1 plus f of, I want to swap it, I want to flip it obviously, right? So I'll be going to the third index and I'll be flipping it. If I flipped it, it will be becoming 0 will be becoming 1, right? So it will be remains as 1. Can you understand this? Yes. Similarly here 2 comma 1 means I am at the particular point, second index is 0 and my previous is 1, contradiction. So here also I will be doing the same thing, 1 plus f of 3 comma 1. Okay, and then here 2 comma 1, here also I will be doing the same thing, f of 3 comma 1. Can you understand this? Okay, fine. Now 3 comma 1 means what? 3 comma 1 means I am standing at this 3, which means its value is 1, okay, and my previous value is also 1. Okay, it is valid, right? It is valid. So which means I cannot have my current as 0. I cannot flip it, right? I cannot flip it because after 1 there cannot be 0. So I cannot flip it. So it is valid. So write valid, and here also valid, and here also it is valid. Can I understand this? What I did? 3 comma 1 means I am standing at third index value is 1, okay, and my previous is also 1. Then why should I flip my current thing? I cannot flip my current thing, right? So keep as it is, okay, fine. Now what is the next thing? The next thing is 4th index is 1, okay, and my previous is also 1. Here also you don't do anything, just go to the 5th index. Can I understand this, right? So this is the reason why I told you want to be clear with the recursion tree and recursion concept. If not, you cannot understand this, okay, fine. Now what is the 5th index? 5th index is 0. And what is my previous? Previous is 1 for everything, right? 1, okay, which means my previous is 1 and current is 0. Here I have contradiction. Whenever I occur the contradiction, what should I do? I want to flip it, right? So flip it means 1 plus f of 6 comma, I flipped 0 to 1, which means my previous is also 1. It remains 1, okay. Here also it will be 1 plus f of 6 comma 1. Here also it will be 1 plus f of 6 comma 1. Can you understand up to this? Okay. Now here comes a crucial part. What is it? What is the 6th index? It is nothing. Whenever I just hit the length of that array, when my index, so this is going to be the base condition. When my index hit the length, I just return 0. Because beyond that you don't have anything. So just return 0. So here it will be returning 0. Okay, sorry. For this particular thing, it will goes on and it will be returning 0. Okay, so this value will be replaced as 0. 1 plus 0 will be 1. Again, it also return 1 and it also return 1. Now this will be substituted at 1. 1 plus 1 which is equal to 2. Again, it also return 2. Again, it is substituted as 2. 2 plus 1 which is equal to 3. Okay. Similarly, come here. Here it will be replaced as 0. So 0 plus 1 it will be 1. Here also it returns 1, and here it will be substituted as 1. 1 plus 1 which is equal to 2. Here it will be substituted as 2. 2 plus 1 which is equal to 3. Okay, fine. Here 0 plus 1 will be 1, and it is substituted as 1. 1 plus 1 which is equal to 2. So 2 is returned from here, and from here it will be returning 2. So from my right side it is returning 2, and from my left side it is returning 3. So what they asked in the question, they are asking us to find the minimum number of flips. So which is minimum? 2 is minimum. So return 2. Again 2 or 3. 2 is minimum. So return 2. So 2 is going to be my output. Can you understand this? So see here, what is the output? It is 2. So this is how the recursion works. So it is basically like what I done is I will be taking the varying parameter as current index and its previous value. If see here, let me write here for your understanding purpose. If my current is 1 and previous is also 1, okay, then I don't have anything, just skip and move on, just skip and move on, okay. If my current is 1 and previous is 0, I have two choices. I can either take this as 0 and 0 with plus 1 operation, or else skip. Similarly, if I take 0 and 0, I have one operation like 0 and 1. Make this the current thing as flip and one operation, okay, or else just skip. If it is what is the leftover 1 0, here I don't have any choice. Conformly, it is going to be one operation, and make this as 1 1. Okay, so these are the 4 possibilities I can get from my current and previous. That's what I done here also. Now tell me what is going to be the time complexity. Time complexity will be O of 2 power n and space complexity will be O of n. So this is how your time and space complexity analysis will be. Fine. Now let us see the code so that you can understand this clearly. See here, this is going to be a Java code. If you want C++ or Python, just go and search in the description. There I have given the C++ and Python code. Now see here, string s and n are I assigned apart from the function so that it will be accessible for everywhere inside this class. Okay, so these are the members of the class, and here I just assign those values, and here there is a recursion. So these are all the basic things. Now come to this recursion function. So here our code starts. So first one is base condition, okay, and then what should I do? I want to check whether my current is 0 or 1. If my current is 0, I have two possibilities. Either my previous can be 0 or my previous can be 1. Okay, if it is 0, then I have two possibilities. I can change my current into 1 and add one operation, or else I'll be skipping it and going to the next thing. Can you understand this? So here it is a skip thing. So I'll be skipping it and going to the next thing so that my previous will be 0 only. Or else I'll be adding 1 to my operation and I will be flipping it. Can you understand this? Okay. Now else means what? The current is the previous is 1. The previous is 1 and current is 0, which means what? Definitely we want to flip it. That's the reason why I just definitely flipped it. Okay. Similarly for the current is equal to 1 also. Current is 1 means previous can be of two things. One is 1. 1 means we want to just skip it. Okay. Or else we want to check which is minimum among the flip and also not flip, which means skip. Okay. And at last I will be returning the result. That's it. So this is going to be your entire recursion code. Now let me take you the recursion code, and let us find out how we are going to optimize it, because this is of 2 power n. 2 power n means it is a huge thing. Okay, this cannot be submitted. Okay, that's the reason why we are just getting into the second step called memoization. So memoization can be done using hash map and also array, but I prefer array. And if you want to do in an immediate manner, or if you don't have any time, just go and find out the hash map approach. Okay, just do the hash map approach. But now I will be teaching the array approach. After you learned about the array approach, the hash map approach is going to be very easy. But the array approach is going to be more time efficient and also space efficient. I will be telling you why. Okay, so see here how many varying parameters are there in this particular recursion. So there are 2 varying parameters, which means we want to design 2D array. Okay, fine. So now we just decided we want to design the 2D array. What is going to be its size? Okay, for that we want to check from where to where this I and previous are there. Okay, so what this I starting from? This I will be starting from 0 and going up to n minus 1. If it goes to n, it will be returned here, right? So I will be starting from 0 and going up to n minus 1. Okay. Similarly for previous, it will be going from 0 up to 1. That's it. So this is going to be your entire matrix. Now what is its dimension? Its dimension is going to be n cross 2. So this is going to be your matrix. Okay, now the next step is, what should I fill everywhere? So for that, just go to the top. See here, what is the all the values here? So here it will be returning only the positive values. The return values will be 3, 2 or 1, like that only. So it will be a positive value. So here let us just put everything as a negative value or infinity or minus infinity or null. That's your wish. Here I will be putting as -1, -1, -1. Okay, everything is -1. Fine. Or if you want null, just put everything as null. That's your wish. That's your wish. Okay, fine. Now see here, in memoization, follow the white color. In memoization, here it is what? F of 2 comma 1, right? F of 2 comma 1. Here it is again f of 2 comma 1. Here also again it is f of 2 comma 1. Okay, which means same thing is repeated again and again. Instead of going for all this recursion, if I store the written value here in my memory, then I'll be using this again and again here, right? Instead of going for all the recursion thing. That's the main core logic of the memoization. So to make this code into a memoization, I want to add a base condition here. After the base condition, I want to add one more base condition, like take for example, if this array's name is catchy, okay, catchy of, sorry, if catchy of I and previous is not equal to -1, then I want to return that particular value in the catchy. That's it. Okay, so this is going to be one of the base condition, and another one is I want to add here, instead of returning directly, I'll be returning after storing it. Like this. Okay, why I'm doing this? See here, this is called updation. I'm just updating each and everything after computing it. Here I'm just checking whether it is computed already. If it is already computed, then don't go to anywhere else. Just return there itself. Can you understand this? So this is what I have done here, and my time complexity now will be of O of n, and space complexity will be of O of n. Hugely dropped, right? Okay, now the space complexity is because of two things. One is because of the recursion stack we used, and another one is because of the matrix we used. Okay, so let us just see the code, then we can go and optimize it further. Just a minute, we comment this out. Yes, so see here, so this is going to be your memoization code. So first of all, I want to design the matrix. Okay, now everything I filled with -1. If you want, you can fill it with null also. If you want, you can fill it with infinity or minus infinity, because they are the things we cannot expect from the written values, right? Or -2, -3, that's your wish. It depends on the problem statement. Okay, now here the only line I changed, and here the only line I changed. In C++ and Python, you cannot do this directly. You want to store this first, then you want to return it. Okay, in Java it is like that. Fine. So this is what the memoization code is. Now let us go into the next optimization technique called tabulation. So this part is going to be much trickier than this memoization technique. So here also you want to follow some set of rules. That's it. Okay. Now it is called tabulation. So before going into tabulation, why we want tabulation? Let us just check about it. See here, in memoization, this space complexity is because of one is recursion stack and matrix. Why this recursion stack is occurring? Because we are using the recursion. If I don't use this recursion, then this space can be eliminated, right? So here we are going to use looping. Okay. For this, the first step is I want to modify the array. I want to check whether I want to modify the array. Okay, how I am going to check it? So see here, always follow the base condition. So what is the base condition? It is I is equal to n, then I want to return 0. Okay, whether I have n. No, I gone up to what? n minus 1 only. So I want to add one more row. And make this as 0, 0. Can you understand this? So let me write here. So till now, how my array looks like, it will be 0, 1, 2 and going up to n minus 1, and here it will be of 0 and 1. But now we need I which is equal to n also. So add one more row, and what is its return value? It is 0. So add 0 also. Okay, remaining value you may take as -1 or anything, that's your wish. If you don't take it also fine, it's also fine. Okay, but this part is going to be very much important. So this is the first modification I have done in the matrix. Okay, what is the next thing? Whether we have any other base condition? No. So always skip this line we added in the memoization. Okay, now rest of them is a body, So whenever we reach the body, just put the for loop, Now what is a for loop? So for, what is the first varying parameter? It is I is starting from where? It is starting from 0 and going up to where? N minus 1. So do in a reverse fashion, which means starting from n minus 1 and going up to 0. Okay. Similarly, what is the next varying parameter? It is previous, and previous will be starting from 0 and going up to 1 only. So here it is fixed range. So we put it as it is, or you may also do in a reverse fashion. That's your wish. Here I will be putting as it is, 0 to 1, because it's a constant, right? Whenever it is a constant, you want to put in the inner for loop, and also you don't want to change its order. Okay, whenever it is varying, you want to change its order. Okay, fine. What is the body? Body is, see here, this line, char ch is equal to s of I, and then I just declare the result. Now put the if condition and all. If my c is equal to 0, then what should I do? I want to go inside previous is equal to 0, equal to 0 means I want to go inside, and here I want to do something. I cannot write the entire thing here. Okay, sorry. So here I will be updating it. So see here, instead of this recursion call, whenever there is a recursion call, just put the name of this array. Let us assume this array name is dp. Okay, just put dp, and here what are the varying parameter? It is I plus 1 and 0. So instead of this, just put I plus 1 and 0. Similarly here also dp of I plus 1 and 1. Similarly here also I want to change this as dp of I plus 1 and 1. Similarly here also I want to change this to dp of I plus 1 and 1. Similarly here also I want to change to dp of I plus 1 and 0. Here also I want to change to dp of I plus 1 and 1. Can you understand this? Okay, fine. Okay, at last, what should I return? So here it will be dp of I and previous only. Okay, there and all, there is no change. What should I return at last? So what I returned here in the memoization, I returned like, see here, let me show you. So I returned flip of 0, 0. Which means the recursion call. So here I want to use dp of 0 and 0. So I want to return this. Can you understand this? Okay. So this is how the tabulation works. Now what is the time complexity? It will be O of n, and space complexity will be O of n, because only of the matrix we used, not because of the recursion stack. Okay. So if you already saw my dp series, then you can understand this clearly. Okay. If not, it will be slightly difficult to understand, but my advice is go and dry run this so that you can understand this and follow the rules what I used here. Okay. Now let me show you the code. Just a minute. So this is going to be your tabulation code. Okay. So see here, what are the changes I done? So first of all, I just incremented my rows by 1, because in my base condition I used n also, right? And then here I did in the reverse fashion. Okay. And here I will be starting from 0 and going up to 1 for the previous, and entire remaining thing will be same, but here we are using a recursion call. Instead of that, I will be using the dp array. That's it, everything. And at last I will be returning the dp of 0, 0, because there also we are just doing a recursion call for 0, 0. Here also you want to return dp of 0 and 0. Can you understand this? Okay. So this is going to be a tabulation code. Let me just copy this. Now let us see how we are going to do in a space optimization approach. So now it is going to be space optimization. It is the fourth step, space optimization. Okay. So In space optimization, we are going to check whether we need entire array or not, the entire array or not. So see here, always for the space optimization, go to the inner for loop. Okay, in inner for loop, what are the things we used? dp of I plus 1 and 0, dp of I plus 1 and 1, dp of I plus 1 here, dp of I plus 1 here, and here also dp of I plus 1, here also dp of I plus 1, and here it is dp of I, which means we used only two rows, I and I plus 1. So let me take this as next and current. So this next represent dp of I plus 1 and this current represent dp of I. So here it will be of 2 size. Here it will be of 2 size similarly. Okay. So instead of this dp, this line, this particular line, I just converted into these two lines. Okay. Now what is the next step? Write everything as it is. Write everything as it is and fill this as zeros. Fill this as zeros initially. Okay. Or else the default value is also 0. So don't worry. Okay. Now come here. Here it is dp of I plus 1. Wherever it is dp of I plus 1, change into next. Because next is representing the dp of I plus 1 here. Here also next. Here also next. Here also next. And here also it is next. And here it will be current. dp of I means it is current. At last, after finishing this inner for loop, I want to add one more line. Next is equal to current. So this line is very important. Okay. And at last, what should I return? Either you can return next of 0 or you can return current of 0. That's your wish. Okay. Because both the things will be same when it reaches this line. Okay. What this method signifies? This method signifies like at first time I'll be only taking these two rows and computing the result for this particular row, n-1 row. Then I'll be taking n-1 and n-2 row and I'll be computing everything and storing in n-2. Then I'll be taking n-2 and n-3 row, okay, and computing everything and storing in n-3. Okay, at last I'll be taking only 0 and 1 and everything will be stored in 0th row, and that 0th row value will be returned here. Can you understand this? So now tell me, what is the time complexity? It will be O of n, and space complexity will be O of 1. Why? Because what I used only 4 spaces, 4 variables. Okay, so here we can also do this without using these two things. I can also do this using dp of 2 space. Okay, but I don't want to confuse you. That's the reason why I am going with this approach. Okay, once you are mastered with the dp, you can also solve this using this thing. Okay, so let me show you the code, then we can go to the next approach called greedy approach. Okay, that will be a quick 10 minutes. Okay, fine. So see here everything is I said, right? So this current and next will be of 2 size, and then everything will be same, but here wherever it is dp of I plus 1, I will be changing into next, here next, and here and all. Okay, and here it is dp of I, so I change it into current. Okay, similarly here I want to assign the current into next, and at last I will be returning the next of 0 or current of 0. That's your wish, because they both are assigned in globally. Okay, fine. So this is going to be your overall space optimized code. So now we finished up to the dp. Now it's time to see the greedy algorithm. So just a minute. So this greedy algorithm will be quite tricky, but if you practice more and more greedy algorithm, then it will be a small problem. Okay, because when I first solved this, I solved it in a greedy only. Then only I thought like I want to teach you the dp approach also, because when you are going for an interview, they will be asking for you for more approaches, because they want to test your thinking ability. That's the reason why I want you to understand the dp approach also. Okay, when I first solve this problem, I use the greedy. Okay, fine. So see here, let me take example 0 1 0 1 1 0 0 1 0 1 1 0. Okay, fine. Now we are going to start with the greedy approach. So see here, what we want is, we want to count number of ones, and we want to take care of how many times we flipped. For example, let us take result. Okay, let us take result. Result will be initially equal to 0, and I want how many number of ones, hats of now from my left side. From my left side, if any swap required, which means any flip or operations required. Okay, so 1 is also 0. Okay, listen this carefully. This is bit confusing, so please listen this carefully. So I'll be starting from the index number 0. So it is what? It is 0. Okay, 0 means what it signifies? If I have anything in my left side, if I have anything in my left side, all should be 0. If I have anything in my left side, all should be 0. There cannot be 1. There cannot be 1. This is what the 0 represent, right? So here I will be doing what is the minimum among result and 1. It is 0. So update that 0 in my result. Can I understand this? Can I understand this? If 1 is not occurred in front of any zeros, then this variable 1 will be always 0. So this is what the greedy approach. Okay, now I'll be going to the next thing. So here it is 1. Okay, 1 means I want to make this as 1. That's it. I don't want to do anything because I got 1. So I don't want to flip anything. I will be taking that 1 as it is. Okay, now go to the next thing. This is what 0. Okay, 0 means what it represent? It represent, hey, I am 0. In my left side, there cannot be 0. There cannot be 1. All should be 0. Or else, if in front of me there is 1, like I am 0, in front of me there is only 1, I will be changing myself. If there is 2 ones, I will be definitely changing myself. Because see here, if it is only 1, then I can change this as 0. But if it is of 2 ones, then instead of changing this 2 ones into 0, I will be changing myself into 1. Can you understand this? Similarly, here also, what we do is, we want to take what is the minimum among this result plus 1 and this 1. Why I am doing result plus 1 and this 1? Because I am doing a flip here. Which means that flip also going into my result only. So 0 plus 1 and 1, which is minimum? 1 is minimum. So make this as 1. That's it. Okay. Now go to the next thing. Here it is what? 1. 1 means what I told you. I want to make this as 2. Again it is 1. So make this as 3. Again it is what? 0. Now comes the scenario. See here the 0 has 2 choices. There's 2 choices. Either I will be changing into 1, or in front of me everyone change into 0. If I want to change in front of me everyone into 0, I want to change 3 things, 3 ones into 0. Whether changing 3 ones into 0 is good or changing myself is good. Can I understand this? So again 1 plus 1 or 3, which is minimum. 2 is minimum. So make this result as 2. So that's it. So 2 is going to be my output. Can I understand this? Now tell me what is the time complexity? It will be O of n, and space complexity will be O of 1. That's it. So this is going to be your greedy approach. But thinking about this greedy approach and solving all the edge cases will be headache. But once you solve as much as greedy problem, then it will be much more easy. Okay. Now for this also let me show you the code. So see here, only 4 lines. Okay. So see here, first of all flip and 1 will be 0. There I written result, right? So here it is flip. That's it. So I'll be traversing across all the elements. Now I'm checking whether the current element is 1. If it is so, then 1 will be added 1 time. Okay. Or else what should I do? If it is 0, then what should I do? I want to check whether I want to change myself or I want to change any ones in front of me. Okay, which is minimum, I will be changing that. Okay, and then at last I will be returning the number of flips. That's it. So this is going to be your greedy approach. So here we have seen about 5 approaches. Okay, 4 of DP optimization, and 5th approach is going to be your greedy approach. If you understood this problem and really like this video, subscribe to my channel, and you can go and search in my YouTube channel. There are plenty of algorithms like this. Okay, and I describe them very precisely. You can go and learn that. So it will be so much helpful once you are going for a technical round. Okay, so if you have any doubts regarding this, just comment below, and if you found any mistakes, then also you can comment below, because here we can do this simply also. We can do this tabulation in simple manner, but I do not prefer like that. I prefer like, I want you to understand how we are going to convert from this into tabulation. Okay, the memorization into tabulation. Okay, I don't want you to go like a pro level. I want you to become like from beginner to intermediate, then you can proceed. Okay, I want you to understand it, that's it. Okay, so if you have any other optimized approach or any other approaches, just comment below. Thank you.